our world and beyond, space, in partnership with the European Space Agency.
Payerne, near Lake Neuchâtel in Switzerland, is one of the country's most important air bases. It's also the headquarters of the Clandel Flying Club, whose members go up in veteran fighter jets, lovingly maintained. This Hawker Hunter is flown by a certain professor at Lausanne Polytechnic, a man who, in the tight world of astronauts, is a living legend.
Okay.
I had 4 space flights in the 90s, including 2 flights to the Hubble Space Telescope. It brought me closer to astronomy when I was fixing Hubble, for obvious reasons. And at the same time, the scenery in space when you're on low Earth orbit, and we had Venus also in the sky most of the time, except when it was very close to the sun, but most of the time we could see Venus.
Hubble is so complex to work on, astronauts get little time to stargaze or admire the morning and evening star of Venus, rising and falling.
The appearance of Venus with the naked eye after sunset or before sunrise is so magnificent. When you have these beautiful colors of the sunset, and it becomes darker and darker, and you have these orange colors, and then it is very bright object in the sky, which is Venus, of course, the brightest object in the sky after the sun and the moon. It's really beautiful.
Venus, along with Mars, is the Earth's closest planetary neighbor, a whisker over 43 million kilometers away. The planet symbolizes beauty and love in many cultures. Always an object of fascination for astronomers, its transit across the face of the sun was a great event. And the event is considered no less important by today's astronomers. The next transit comes in June this year, and observatories around the world are alive with activity. At Europe's Space Astronomy Centre, ISAC, near Madrid, the team's already rehearsing the complex observation that we'll be able to follow in its entirety on the internet.
We have here 2 telescopes. One is a classical optical telescope, and the other one is a solar telescope, which is specially designed for solar observation, so you cannot use it for anything else. And it observes a very narrow line in the orange, and it allows you to see really what's going on the sun. And we will have 2 expeditions, one to Svalbard in the north of Norway, and one to Australia. And we will transmit images, so we will have a web page dedicated to that, where you can follow it directly, the Venus transit.
The transit of Venus inspires. The last one was in 2004, but before that it was 1882, when it left such an impression on John Philip Sousa, the American composer, that he decided to celebrate the event in the only way he knew how. After this June's appearance, we'll have to wait until 2117 to see the transit again. Back in Spain, where the ISAC centralizes all the data from the European Space Agency's missions, Venus specialists recently met to pore over the latest data and sum up what we know about our so-called twin planet.
And then we're of course also studying the plasma environment and what is outside the planet.
In the 50s and in the earlier days, it was in general believed that Venus was quite similar to the Earth, and there was a dense atmosphere that was known, but it was also thought that there was a lot of water vapor in the atmosphere, and the cloud layer was just like the Earth's cloud layer. So we had some similar situation like in the jungle. So there were being pictures drawn in those days of jungle landscapes and even creatures living down on the surface, very much similar to on the Earth. By radio astronomy observations, that detected that it seemed like in the radio frequency range the radiation from the planet indicated that the temperature was much, much higher than on the Earth. Many people didn't believe that, they didn't trust those measurements. But when the mariner made the flyby of Venus, they had real reliable instruments that showed that the initial measurements were indeed right and the temperature was very, very high.
After Russian and American missions, ESA decided to join in the exploration of Venus. So Venus Express was launched in 2005. A Soyuz rocket put the 1,250-kilo probe into orbit, the start of its long journey to Venus. It would arrive 153 days later.
In the beginning, we did a few very, very elliptical orbits taking us very far from the planet, so we could do long sequences of observations from long distance. And that was very useful to see and track how the motion of the weather patterns were moving. And then we were finally, after a few weeks, coming into our final orbit. Since then we have done a large number of different measurements with the 7 instruments we have on board. They are covering spectral ranges from the ultraviolet into the visible range, a bit into the infrared range. And the infrared observations are particularly interesting because we can probe through the dense atmosphere and through the cloud layer, and even at 1 micron wavelength we can see all the way down to the surface, in fact.
In the stony mountains that surround the Spanish capital, Madrid, a 35-meter dish stands out in the rustic surroundings. "50 kilometers away, ESAC's computers whir and buzz as they crunch numbers around the clock.
Data are sent by the Venus Express spacecraft to the antenna in Cebreros, and this is called raw data. Then this raw data is being transferred from Cebreros to the ESA Mission Operations Center in Darmstadt. We receive here the scientific data from the instrument teams. They are being validated and checked to make sure they are of the highest quality, and then they are being archived here on this big computer server.
So once the data is put into readable form, it is distributed to the widest possible audience, from experts to the general public.
We can have some spectrum related to the density of the Venus atmosphere. We can have also information about the winds across around the poles of Venus. And all this data, this final material, can then be accessible online through the Venus Express archive website.
After 6 years of intensive observation, what more do we know about Venus's mysteries? Well, with a surface temperature of around 400 degrees, the least we can say is it's a hostile environment. But there's more.
Venus takes 220 days to go around the Sun. It's a bit closer. But the day is in the opposite direction to the Earth's rotation, and it takes 240 days, but in the opposite direction. We don't understand this at all. It's completely unlike the other planets in the solar system. It could be that it's some a collision that happened early on in the life of Venus. It could be some other effect due to the very dense atmosphere and interactions with the sun and so on. We simply don't know.
Ultraviolet rays penetrated the thick, mostly carbon dioxide and sulfur atmosphere, stripping away the hydrogen. This left a waterless planet subjected to strange, violent winds.
On the surface of Venus, the wind speed is rather low. It's a rather gentle wind. But high up in the clouds, about 100 kilometers from the surface, the wind speeds are very, very high. The wind is traveling at 300 kilometers an hour, and it travels around Venus every 4 to 5 days. So that's one of the things we don't understand, why at the surface the winds are very gentle, and high up the winds are very, very fast.
Venus Express revealed a gently sloped landscape with vast volcanic-looking plains. It's thought the planet's internal heat escapes through lava flows, and a number of volcanoes have been found.
We know very little about the nucleus of Venus, whether there's like the Earth, we have a core and then a mantle. We don't know whether that's the case on Venus yet. The Earth's surface is constantly renewed by plate tectonics. The Earth's surface is about a quarter of the age of Venus's surface. Venus doesn't suffer from plate tectonics, and again that's an interesting difference which we don't understand between the two planets.
Venus is a planet that guards its secrets well. We still know little about its surface or atmosphere, but that mystery still tugs us heavenwards to explore and discover.
We're discovering new things all the time. For example, one of the very interesting discoveries of Venus was a huge vortex, a huge cloud at one of the poles of Venus that in some ways looks very similar to a hurricane on the Earth. But this is a long-standing event that's there all the time, and we don't understand how it's formed, why it's there, and how it will evolve.
Venus Express was designed to run for 2 Venusian days, or around 500 Earth days, but has proved so reliable. The satellite's mission has been extended several times. When its life does come to an end, it will crash into Venus's surface.
We will learn more about the whole evolution of the planets in the solar system, the inner planets of the solar system, including the Earth, from the start after the formation and also until the future of maybe millions of years from now, by better understanding how planets work all together in their interaction with the Sun and in their internal evolution.
What comes next is the interesting thing. At the moment, there are no other probes planned to Venus. When Venus Express ends its mission in 2015 or 2016, we're then going to be in a period where we can't monitor and we won't be able to learn any more about Venus. And hopefully this is something that one of the major space agencies will pick up and we will get a mission in the next few years.
The adventure will continue for years yet. But why this incessant quest, this desire to discover?
The ants and the butterflies, however they are beautiful, the butterfly, they don't ask themselves any questions about their origin, about the universe, about formation of stars and planets. We have all these questions because we are human beings, and it is in our nature to explore as human beings.